today's webinar, we have one of Dell's most valued reseller partners, Sterling. And today you're going to be hearing from Sterling's CTO, Chris Sear. Chris is responsible for the overall technology strategy, including Sterling's vision of enabling high-performance, highly automated cloud and technical innovations. Before joining Sterling, Chris served as the enterprise cloud architect and founding member of the cloud pursuit team, cloud execution team, and cloud technology office for Oracle. With over 28 years of working as a technical evangelist and enterprise architect supporting the federal government, public sector, and commercial markets, Chris is an advocate for the client-to-cloud offering at Sterling. So with that, I'm going to turn it over to Chris as our presenter. Take it away.
Great, thanks, Joe. Yes, I am Chris Sear. A little bit about myself. I've served in the United States Air Force under Special Operations Command up at Hurlburt Field. Spent about several decades supporting the warfighter and command and control systems. And then I also spent 5 years working for the United Space Alliance, working as a middle tier information architect for asset management for Space Shuttle and Space Station down here in Merritt Island, Florida. And then on top of that, I actually worked at Sterling prior to coming back as CTO, as an enterprise architect for them for 9 years, doing a ton of different engagements with the United States Air Force, Lockheed Martin, and the U.S. Navy, to name a couple. Throughout this time, I'm going to kind of tell you a little bit of a story about something that that I've been doing, outside of my profession, but driving myself, personally forward in creating an impact in how we, humanity ourselves go out saving lives. And there's a little bit of, story about Sterling. There's a story about some of the vehicles that I use and how they get used. And then the application of technology and the culmination of my knowledge and my team's knowledge and Sterling's capabilities to be able to bring it to this next point for the future. If you see the picture on this first slide, there's an interesting story behind this. If you ever saw the movie Monsters Incorporated, there's a little scene where Mike Wazowski, the little green monster, is like, "Oh my God, I'm famous," and and you're looking for him, and there's like down the left-hand corner is a little picture of his eyeball. But in this particular picture, this was on the cover of USA Today, and and I became famous because right behind that woman's head is the back of my head. It was a really great photo opportunity for these two people. And my partner and I, Bill Zhang, where we run this hovercraft rescue team, we didn't really know the picture was being taken. The story behind this is the gentleman that's in the hat. He decided he needed to walk across to try and save his sister, the woman that he's hugging right now, and he got stuck up on a bridge on the interstate that had become overflowed. And swift water was flowing over his shoulders, and he was pinned up against a concrete embankment. We had one boat from the police force go and try and save him. That boat flipped over and got washed down. A couple of jet skis went out to try, and wave runners tried to go out and grab him. Those two flipped over and got washed downstream. And then finally we were with the USA Today team, and they looked at us and said, "Hey, would you like to see if you could go rescue this gentleman?" And we did, and it took a total of 7 minutes for us to do so. And I'll tell you a little bit about that, the capabilities there. The vehicle that we did perform that rescue was the one on the left, the big blue one. So, how does Sterling get involved in something like this? It's really interesting. For 2 decades, Sterling has provided industry experience. I'm proud to have taken, a part of those 2 decades across that span, helping, Sterling grow and also building my professional career. And with that, as I've noticed, we've have industry leading partnerships. And it's not just partnerships in which we sell, goods and services to our customers. I mean, which is kind of what we do. But the big thing is that we have strategic partnerships, right? We're really in closely with their technology roadmaps. We're really in closely with the way that their business strategy is laid out. And when we work in unison with our vendors to drive these strategies forward and evangelize them to our customers, right? Because we believe with our customers, knowledge is power, right? You all have purchasing power, and if you don't know the entire landscape of the products and services that can help you achieve your strategy, right? Your business strategy or your technical strategy, then we would be doing a disservice to you. And on top of that, our people are one of our greatest assets. We have a massively wide range of technical certifications, all the way, from VMware to Dell Technologies, EMC, Red Hat. The list goes on and on. AWS and all of the cloud providers, in which not only are just our engineers that provide sales engineering and solutioning, but also the delivery aspects of it too. Which is the reason why, you'll probably hear the words client to cloud, because that's really what we are. It's really what Sterling does. It's all the way from a handheld device or a laptop or a Chromebook or a sensor, all the way through the entire range of connectivity out into cloud and also with managed services. So we're based, our headquarters is based in North Sioux City, South Dakota. We've got a little map here. We have additional sales offices in Norfolk, Nebraska, Omaha, Austin, and then we have also some configuration, integration, and distribution centers in Sacramento and in Dulles, where we do a lot of our packaging and configuration of clients and servers and equipment and getting them completely turnkey ready to deploy to our customers. Now, down on the lower right-hand side, you'll see Florida with a little rocket ship there. That's where I'm at. I'm in Merritt Island, Florida, just outside the gate of Kennedy Space Center. So, I get to walk on my back porch and see, ULA launch the rockets and SpaceX do the same. So it's really a wonderful place to be. The picture is of our headquarters down the lower right-hand side. And right up above that is our brand new solution center where, once everybody's be able to travel, I'd love to invite you out to come see all of the different solutions that we have in person. But we can also provide demonstrations remotely. Now, when we say client to cloud, I mean, it's a great buzzword, things like that. But this is what we call Planet Sterling, and right at our core are our client services. It's not just going out and, and selling a Chromebook or selling a laptop or a tablet. It's really what do we do to provide added value to our customer. We laser engrave. We can do remediation, redaction of devices into these units. We can configure them using gold disk images. And I mean, we even do things such as, get rid of all the cardboard and packing materials and put them into, your briefcase or your backpacks and asset tag them and even embroider them to whatever, logos that you want to have on the outside, all the way to moving out into a more modern data center, right? Where we do all the systems integration with a massive range of equipment and software offerings, where we provide, network design and configuration, as well as security architectures and identity management, data protection for being able to provide, backups and recovery equipment and services. And then as we start branching out into that cloud space, it doesn't just mean we're going out to AWS or Azure. We also deal with private clouds and hybrid cloud connectivity as well. We're specialists in software-defined data centers, IoT and edge compute, all sorts of mission and business continuity, all the way up to a TSSCI cleared level and in the commercial world as well. And then our engineers also do performance optimization it's an interesting story. I actually went to go work for United Space Alliance because that was really what I specialized in, was solving those problems with performance in an entire data center process. And then how do you operationalize cloud? A lot of times what I've experienced when I was working, at Oracle was, agencies and companies would spend the money to get a cloud environment, and then they wouldn't really know the questions to ask, like, how do I get identity management to work in that? How do I make sure that the network that I'm connecting to cloud is secure? How is it optimized? How do I get, all of my compute assets to be working right? Is it sized properly? All the way down to like the management operationalization, right? Do your existing systems administrators know how to be able to perform the same tasks that they've done, in an on-premises data center, to be able to do that in cloud? So that is part of, our cloud story. And then above all, we've got security, right? So as I mentioned before, we're a top secret facility clearance organization. We have cleared personnel that go in. We've been doing, STIG checklists for decades, on some of the highest performant weapon systems that are out across all the agencies. And we apply that even into the commercial sector as well, working within HIPAA and also within our secure supply chain, which we're getting ready to go to CMMC level 5. And then the next stage that we had was to go into, a managed services provider, where even if you don't understand cloud, even if you need work within that data center, even if you're losing some of your resources within the network and security space, we provide managed services across the board for all of those different services. And then the final outer lying ring of this planet is, we're here to be able to transform your business, right? We understand the mission and the business requirements that are coming down the pipe because we work so hard with our customers to understand that strategic roadmap, both with our vendors and our customers. And then what do we do with all this data? We understand data governance. One of the big things that we did was develop the data governance plan for Missile Defense Agency. And then, then how do you tie all that into to make sure that you're meeting all the regulatory compliance? So that's our entire span from client to cloud, all the way from the smallest device to the largest weapon systems that reach across the globe, in a most secure and performance optimized process as possible. So how do you get to us, right? So we have a bunch of different federal contracts, state, local contracts within education as well. We also have, the ability to reach out and do business in the commercial space. These are just some of the different areas of the commercial business within the medical world, financial, manufacturing, engineering, but it's not the only far-reaching areas. Within state and local and education, I mean, we go all the way down to, elementary schools that are trying to develop a STEM program and be able to, outfit those classrooms with the right activities and materials so that the teachers don't have to spend all their time doing that work. And then from the federal side, with the new ADMC contract, 2GIT, hopefully coming out. But we also, we're a big SOUP 5 contractor, as well as, being able to be reached on GSA contracts as well. So we're completely accessible from all areas of our customer base. And then that being said, if you want to see something, if you actually want to see how things work, we've created this new solution center at our headquarters. And here's a little picture of it. Of course, right now, there's additional racks that are going to be in. It's not just the one, but we are building this out, and we're bringing in, new partners and new solution sets to be able to grow this entire client to cloud, idea that we have and strategy that we have for our customer base. I'm not going to read all this to you. This is kind of like an eye chart, but there are some really important demonstrations that we're capable of being able to do. Automating, right? How do you automate your on-premises and cloud environments? How do you look at cross-cloud Kubernetes management if you're looking at containerization, right? If you've seen VMware rolling out Tanzu, what exactly is Tanzu Mission Control? And if you are running any, VMware, how do you modernize applications that aren't virtualized? How do you learn about the CI/CD pipeline? And then, of course, we have some other demonstrations coming soon, real soon, like within the next couple of weeks, as our virtual desktop infrastructure demonstrations and proof of concept capabilities. Everybody is teleworking. It's all the remote work is now like the new normal because of COVID. And being able to think about creating the right strategy for remote operations is extremely important. And so I hope that I've given you a little bit of an overview about who we are, who Sterling is, and what we're capable of being able to provide. And with that, knowing all of that, we're going to get into the next step, which is, well, what about these vehicles? You saw the status of what exactly is a hovercraft and what exactly is a hoverwing. So this is just a really simple picture. What is a hovercraft? A lot of times there's commercials that show like helicopters hovering, and they call those hovercraft. And, that's not really it. It's really a vehicle that you can sit in, right, or put something on, and it uses an air cushion. It's a really simple, kind of a simple vehicle. And it rides on a cushion of air, and there's a flexible skirt underneath it where a fan pushes air into the skirt, pushes more air into this cavity, and then as that cavity fills up, it kind of floats like a hockey puck. So there's very little drag, if any, when you're what we call on cushion, okay? And then that fan either creates the lift and thrust at the same time. Our vehicles, we actually do something different. We put our lift fan up front so that we're actually the fastest hovercraft in the world. And the reason for that is the air coming from the front as you're going really, really fast allows the air to flow throughout the entire craft, and we can actually reach speeds greater than any other hovercraft on the planet. So the other neat thing about these vehicles is you can sit still in a rapid. So swift water is not an issue. You can also drive across any terrain, whether it's sand, mud, snow, ice, water. It doesn't matter if it's 1 foot chop. It doesn't matter if there's waves. Instead of like a boat where the wave pushes the vehicle along with it, that wave actually goes underneath you, and it's a really kind of a different effect that you feel when you're driving this, right? So we took this hovercraft technology through the use of a company that I work with, and we took that technology and we decided to listen to the founder of Universal Hovercraft, who is Robert Went, Uncle Bob, who said, I think I can make one fly, and I think we can get these vehicles up above the ground and kind of get it a little bit more away from the surface. And so with that came the design, what is called the Hoverwing. So what is a hoverwing? Well, it's really kind of simple. It's a hovercraft with wings, right? But these wings allow it to fly several feet above the surface. So when I say several, normally you want to cruise around 5-6 feet. We can pop up much higher, over those trees in the background and the scenery there. But normally what we'd like to do is kind of stay closer to the surface because it's more efficient for us. This other picture to the right, I had to do kind of, an interesting shot because a lot of people, when they say, oh, you do hovercraft, is it like those big Navy ones, right? So that's a Navy LCAC. Yeah, it's very similar. It is a mathematical formula. The reason why that LCAC was created was because they wanted to put an M1 Abrams tank on that vehicle, and that vehicle holds 90 tons. Well, in order to be able to do that, it's a mathematical formula that with hovercraft is very simple, and the dimensions of that vehicle actually match the type of weight that the vehicle needs to transport. So as you can see in this particular craft, this hoverwing has a fan up front. This has gull wing doors. The wings are removable, so it's easy to transport, and and it has some really interesting specifications. But how did we get there, right? So how did all of this come to fruition, and why are we having this discussion now? So I'm not an aerospace engineer. That's not what my degree was ever in. I actually became kind of involved in this by being a science fair judge. And I met this middle school kid that built one of those plywood hovercrafts with a leaf blower, and I thought it was really neat. And then I met Bob Wint, and I met his nephew Bill Zhang, who's my partner. And he showed me this vehicle that flew, and I was like, wow, I need to kind of show this to AFSOC. And 15 years ago, I demonstrated its capabilities. So, there's a little picture of me flying across. If anybody knows Northwest Florida, this is, just out on the other side of Hurlburt Air Force Base, and I'm flying in the Sound. Eventually, we put military members inside of it and flew them in that, and they were like, this is the most amazing thing in the world. I want 100 of these things for a bunch of different missions. It was primarily originally going to be used for infiltration and exfiltration instead of all those inflatable boats that you see special operators in that have to lift them and crawl across, reefs and sandbars and drag them up and bury them and do all sorts of other things so that they can go do their mission. We could fly, land, they climb out, turn around, fly back, slide into a helicopter, and no one else was the wiser. So that looked really, really well. Now notice that date, August of 2005. So the reason why this is important is because the top speed of the Hoverwing is 100 miles an hour. Cruises around 70. Its maximum range is about 600 miles. We can, of course, increase it by adding more fuel. We like to say the max flying height because of the FAA is 15 feet. That flexible skirt that I talk about is 14 inches of clearance between the vehicle and the ground. And the engines that we use are American made. They're General Motors Ecotec supercharged engines with Briggs & Stratton in the front for lift, although we do use electric motors, if necessary. We've done that before too. It seats up to 6 people. And the max weight capacity is about 1,200 pounds. We go higher. It really depends on the amount of lift. It's that mathematical formula that I was telling you about. But we like to kind of stay around the 1,200 pound, category for this particular vehicle, right? So then we get this wonderful conversation with the military, and they said, well, draw up a concept. So this is what we had. It was called the XRW. It was really cool because they wanted to put a gun on it. They wanted to do all these other things. So we developed this concept, right? And you'll notice this vehicle, right? A lot more smoother lines, and we developed, this same concept. It was supposed to be called the HAT, the Hoverwing All-Terrain Transport, and it was a great concept, and we were moving forward with it. But then remember, I told you August 2005. So what happens less than a month later? So Hurricane Katrina hits, and as I mentioned before, I just flew a whole bunch of people to include congressmen and senators and stuff like that. Katrina comes in and wipes out the city. Now, these are my pictures. These are pictures that, that we took 15 years ago. You'll notice that one of them is Canal Street on the left-hand side. If you remember this hurricane, the news agencies were saying, get to the Superdome. Well, the Superdome is in the top middle picture. If you notice how much water is there, it was a little bit difficult for people to get to the Superdome, right? So there was a lot of disinformation as far as where to go, how to be able to even get there, and not only that, but the water itself had 46,000 times the amount of E. coli in it, right? So how did we capture data on throughout this disaster? Well, we didn't. The only capacity that we had, it was before iPhones, right? So we had our own cell phones. Towers were down. We would text people with the hopes that if we ever caught a glimpse of a cell phone signal, that text message would go out. If we did get a signal, then we would make a land marker and put it on a paper map to make sure that if we needed to make a call, that we would go back there and do it. So, we didn't know what the water was like, the quality was like. We didn't know who to be able to deal with. It was really kind of difficult. But there were several good things that came out of it. One was we didn't just go in there. We actually went in through a congressman's congressional order. And this is it right here. And the reason why this is so important was because the line that he put in there that was so impactful was, any attempt to interfere in their already legally arranged use will be prosecuted to the fullest extent of the law. This enabled us to get past every single roadblock. FBI didn't matter, federal law enforcement, New Orleans PD. It allowed us to be able to work with people, and it allowed us to be able to go out and do the things that we wanted to do. But we still didn't have a rescue vehicle, right? I had to grab 7 vehicles from all over the country. People congregated at a particular point, and the vehicles were all different sizes and shapes. None of them were based to perform rescue, okay? But some interesting things did take place. One was National Guard pulled up and said, hey, do these things fit in helicopters? And we said, you know what? We've never done that before. And you said, you want to? And I said, sure, that sounds like fun. And so here we are loading one of our vehicles into a Chinook helicopter. It is rather interesting. They got tired of rescuing people one at a time. They got tired of dropping that hoist. You've probably seen the videos, right? Where they're dropping this hoist and picking up victims and then pulling them up one at a time and then flying away. Instead, we launched these vehicles from the water, slid down, went from land to land throughout all these neighborhoods in New Orleans and picked up several people at a time. They would walk up onto the ramp and then they would fly. Once they got full, they would fly off and do rescue. We would stay, pick up more people, and we managed to save hundreds and hundreds of people's lives because of that, right? So we learned a lot, right? And because we learned a lot, we said, you know what? We need to build our own rescue vehicle. We need to take everything that we learned during Hurricane Katrina, and we need to figure out how to be able to build a rescue vehicle. So this is what we did. We built one. It had a smaller thrust duct because we kept dealing with power lines, right? We wanted to make sure it was enclosed in the event that we were dealing with foul weather, whether it was cold or whether it was, hot. We could air condition it for people. We also wanted some protection from the elements. This is, kind of an interesting rescue. We actually, did like the snowmobile simulation rescue, being able to pick somebody up. To be able to perform a rescue like this in a boat, there's moving parts in the water. There's no moving parts in this vehicle. So even if it is swift water and we run them over, nothing happens to that person, right? On top of that, there's no gunnels. So if this, like a boat does, so if we're picking up this person, it's only 4 inches above that site. We could actually drop off skirt and slide that person up onto the craft and get them on a backboard and take care of the injuries. So there was a ton of information that we gathered during that first operation. And then, what happens if you're doing ice rescue? Well, even on thin ice, the standard operation for ice rescue is tie a rope around a first responder. They crawl out on hands and knees, and they just keep crawling out until they pick somebody up and then drag them back in. Well, that's extremely slow, extremely dangerous for the rescuer, and we can actually get there at 50 miles an hour, pick them up and put them in to safety and get them to an ambulance and get them out. So we've been, we're really fired up when we developed this vehicle. And remember, this is quite a while ago, back 2007, 2008. Well, while we were so excited about this, we decided every natural disaster that comes through, we're going to do the same thing that we did during Hurricane Katrina. So Hurricane Irene comes about, and this one was a doozy, right? Up in the Northeast. So this happened in 2011. So all this media is going on, and I decided, you know what? I saw what was happening. It was getting ready to happen in New York. And so I called Mayor Bloomberg's office, and I got an email address. So I sent this email. This is the actual email that I sent to Mayor Bloomberg. And this was my response. Thank you for contacting the city of New York. We're going to forward you to the appropriate agency. And here is your, for future reference, it's a help desk ticket, right? Sincerely, the city of New York. Take a wild guess what happened. Do you think I got a call? Do you think anybody called me or contacted me or emailed me, right? Absolutely not. Got nothing. Meanwhile, people are still sitting in destroyed areas trying to get rescue. And tons of lives were lost. People, were injured, and they didn't have that level of capacity, which made me get even more angry and continue to send more letters when everything, took place. So this isn't just the only one. I mean, we did Ike, we did, I have a stack of letters like this and responses like this from federal agencies, that I could take up more than just the time that we have allotted to discuss this, right? So, but there were some successes. As I mentioned before, that very first picture of that man that we saved, this is a picture of those boats and those wave runners, right? This is what happened and there were people in these vehicles, right? And those people in those vehicles washed 2 miles downstream, and they had to get rescued as well. Well, guess what happens when you're rescuing rescuers? Now it's a force subtractor, because now there's multitudes of people that can't go out and save lives, right? And so we worked with a bunch of different law enforcement agencies during Harvey. You'll notice here, this is how some people, how they go off and save people or sweep houses in the event of a flood. Now, Harvey, some of the water, you couldn't even do this because it was over your head. It was 10, 15 feet deep in water, but we could slide up onto the roof and we could pound on the roof. And if somebody was there, we'd swing an axe and, open it up and pull people out. But, even 12 years later, there's no data that is helping this law enforcement officer go inside that house. Doesn't know if there's volatile organic compounds while we're standing there, if we're breathing it. They don't know if what the quality of the water is, if there's fuel in it, or if there's, different bacterial growth. We don't know if a dam is burst. We don't know anything. We have no data whatsoever that was taking place at this point. And, and this is just 3 years ago. So, that just encouraged me to keep moving forward. And so what happened after Hurricane Harvey? Then we had Irma, Maria, right? And then in 2018, Hurricane Florence came up. And so myself and another Sterling member, Scott McDuff, my partner, and a ton of other people all got together. Shane Wilkie, who operated the big vehicle that you see the video of. We went to Burgon, North Carolina, because there were 7 horses that were getting ready to die, and a family got evacuated by helicopter, and they weren't even allowed to take any of their additional pets. So we were in Raleigh at the time, and it took us 6 hours to go 90 miles. It took us 6 hours to go 90 miles because we didn't know what roads were open or closed. We didn't know what law enforcement we were going to run into. We didn't know if, like this picture on the lower left-hand side, when you look at that picture, you don't just turn around and head the other way, right? Your GPS doesn't tell you what roads are flooded. This fire truck basically was blocking the street because this county ran out of road signs telling them that the road was washed out, right? This was 20 miles in, so we had to turn back around, go find another way, right? And all the while, there's animals and people that are going through this water in North Carolina, right? Now, the picture on the right-hand side, if you look at that, you'll notice that's a telephone and a power pole, right? Well, they're pretty tall. The roof of the house is right there, and you would think that the water, that house, right, probably about 8 feet deep. Well, I thought so too until they told me that these houses were on stilts. So now imagine what you're dealing with. If you're going through in a boat with a motor, there's cars, there's, all sorts of obstacles under the water. None of that is mapped. You literally have no idea what is sitting underneath that surface. And, in my team, we're swimming the big horses out because we didn't have capability to be able to get them, out via hovercraft. So, now we had to swim them out 2.5 miles to safety. So we learned a lot. Right? We learned a ton just 2 years ago based upon the actions that we did, right? And how on earth could you get a horse on a hovercraft? So this is the world's first time ever that anyone was ever to get, a large animal onto a hovercraft. And this is a 21-foot cargo vehicle that we have, that we've built. And when you take a look at that, there's a lot of things that you've got to do to be able to get a horse to jump out of water and onto a platform like this. Took me about 45 minutes. I'm a certified equine first responder. I work a lot with horses. I own a couple. And it took me about 45 minutes to an hour to get this pony to trust me, to be able to trust me to jump up. The gentleman who was in the water, helping me was my farrier. So he understood horses as well, but we had to get them out of the water, because if you don't get them out of the water or get them to safety, they die. And in Hurricane Harvey, I saw a lot of, dead livestock and dead animals and dead horses as well. So, the capability of this vehicle is extremely important, not just for saving human lives, but saving animals' lives too. This is another Mike Wazowski moment for me, because the only thing that you're seeing now is just my, wet jeans, because I had to jump out of the water and then jump up on the deck. So all of that, do you think that we had, even in 2018, with the iPhones and drones and, smartphones and data, big data and analytics and all of this stuff, do you think that that is prevalent in these environments? The answer is no, it's not. We still had law enforcement agencies, multiple law enforcement agencies, coming down to Burgos, sweeping the same areas of land that we had already done, right? We had swept land that they had already done. People who were coming in had no idea what their houses would look like, and nobody would take them out to visit their houses. So we did. We had cattle that nobody knew how to be able to get food there. So sheriffs were taking, a 45-pound bale of hay and putting it in one little John boat and taking it out to feed 100 head of cattle. We were able to take 45 bales of hay and put it on our large vehicle and transport that out to save those cattle. So there's, this is something I say a lot, right? There's something that happens when you're standing alone on a hovercraft in a city that's 10 feet underwater with nothing else around you, no cell phone towers, your GPS doesn't work because your GPS is probably, Google Maps, and because your cell's not working, you lose signal, right? You get this particular perspective, and as a technologist, I want to have this solution, right? There's got to be a better way. So I decided, okay, I'm going to take the Hoverwing platform that we wanted to utilize for everything that we did, 15 years ago, as we would constantly show videos, right? And I want to turn this into a data platform. And the reason why this is so important is we do this. Okay? Not a helicopter. Anybody can fly it. You don't need a pilot's license to fly it. If it's on the water, it's registered as a boat. If you're on land, it's registered as an ATV, right? It's 30 times cheaper than a helicopter to operate, right? And that's all well and good in terms of that vehicle. But the biggest, most important thing is, what do you do with a platform? Because that's really what this is about. It's a platform, because we need to start collecting data. So what happens in a natural disaster? So I decided we're going to take this platform and we're going to go to our vendors and we're going to talk about, capabilities and what this vehicle can do. And I'm building this data platform, right? So we want sensors on it. We want to look at the volatile organic compounds. We want to look at wind speed and direction. What is the carbon monoxide level, in the areas? Is it safe? Can we breathe? How hot or how cold is it? Are we going to get hypothermic if we go into the water, right? Is the barometric temperature falling? How deep is that water? You'd be amazed that even the law enforcement agencies' boats didn't have depth meters. I watched outboard motor outdrives get completely destroyed as they would cruise across the street. GPS information to be able to track and target things and write things down and record it, right? I want to do LiDAR for 3-dimensional mapping of dangerous areas. And also, water quality data loggers, right? Am I jumping into something that is acid? Am I jumping into something that's safe? And that's just the sensor part. And then cameras, you'll notice that, the quality of the video is not good because why? Well, we did have GoPro cameras, but when you're neck high in water, that doesn't really work out very well unless you're mounted on your helmet. So we didn't really have the helmet mounts. And then what do you do with that data? You pull out the little SD cards or a USB and plug it into laptops, which is really what we had. And then sometimes you'd accidentally touch a button and it wouldn't record. I mentioned infrared, and the reason why that is so important is, in case you don't know, no one does rescue at night. There is no such thing as night rescue. So if you're sitting on the roof of your house and the sun's going down, be prepared, because you're sleeping there, and then someone in the daytime will come get you. Everybody, it still amazes me. So, we've got to be able to, if we have intelligence, if we have the data, we know that it's still safe out there, we can actually go out and perform rescue at night. And then, of course, three-dimensional image sensors, right? Because we need to know what that terrain is going to look like. There's a lot of things that stick up out of the ground that you don't necessarily, see. Right? We also want to be able to record in high definition, because we're going to use machine learning to determine if there is a snake swimming across the water. Because guess what? Snakes swam across us all the time when we were sitting chest high in Burgon, North Carolina. Fire ant balls, if you've never heard of that. But those are extremely painful, right? So we want to be able to record that, and we want to be able to record in every different direction, because not everybody can just see with our eyes and detect a threat or detect something dangerous or detect someone or something that needs to be saved. And then audio, right? We want to be able to record. We want to be able to record and listen, because we may not hear everything. Right? We want to be able to record that audio. Maybe we're hearing a cow moo or a cat whine or a dog bark, and we've missed it because our engines are running behind us. And then, just with those type of, sensors, then what are our engines doing, right? How long am I operating this for? Does my temperature go up as I'm idling? What is my efficiency for my engines? And then, am I putting the right load onto these vehicles? What's my airspeed if I'm flying? What's the vibration like? How much am I in a tilt when I am loading up a horse on a hovercraft, right? What is the water flow and velocity of the surface that's underneath me? How far away is what I'm getting ready to fly towards, right? How far away is an object that I see? And then, as well as that, is like medical data. As we were going through this process of rescue, there wasn't anything that was recording anything about us. Let me tell you something. When you're getting ready to jump into a flooded area, into water that you have no idea what's underneath you or anything like that, it's a little stressful. So the heart rate will go up, right? If you're, as you're swimming a horse out 2.5 miles, your oxygen sat rate is kind of important, right? And then if you're bringing people in that are sick, you want to be able to get some vitals relatively quickly and be able to record that. So those are just some of the minimum requirements that I was looking at for this, for this platform. But what does that bring? It brings all types of data, right? Video, pictures, audio, streaming data from different, devices, right? Structured data, unstructured data, bioinformatics, machinery information, depending upon what we're doing. If we've got drones that are attached, what's going on with all of that data? Is there geopositional data on tags and things that we've targeted, right? All of that requires processing need. We got to have a high-speed data capture network. We got to have data storage capability that can quickly record all of this and trap all of this and keep it safe, right? We got to be able to reconfigure things in the field, because guess what? Things change in periods of disaster and periods of need, and you can't go back and you can't redesign something, right? And then we also want to be able to have processing capability on the vehicle, so that we don't have to reach back somewhere else to be able to provide it, so that we can have actionable intelligence while we're going through, this journey during a disaster response. And then we also do need cloud connectivity, right? We want to be able to utilize the cloud AI and analytics, or we want to be able to use, some additional cloud resources. We might want to be able to send this information back to people that they can be able to see it at an emergency, center, right? Management center. So those were just some of the initial processing needs. So Brad Moore, our CEO, my boss, one of the things that he told me as I was getting ready to become CTO for Sterling, he said, Chris, I want you to think of Sterling as your candy store. And I want you to build solutions that are going to make a difference that our customers can do something with. And so, I to this day, I love that because I do use our vendor partnerships and our customers and I think them of ways of being able to take all these new pieces of technology to be able to develop solutions in which we can help our customers, right? So that's what I did. I went to the candy store. And in doing so, created like this initial design. I didn't want a ton of different vendors. I wanted to look at some capabilities. So with Dell and EMC, we've got a really good relationship. And we get to look at, roadmap strategies and things like that. And we were taking a look at this new PowerScale architecture. And it was really kind of funny because as everybody was looking at it and putting it in our solution center and putting it in a big rack and everything, I'm looking at it and going, wait a minute, it's all solid state. How much does it weigh? What's its power consumption? What are its temperature? And I'm asking Dell this, right? And I guess they weren't too ready for all of the environmental impact, and they didn't really know where I was going with this. But once they did, they realized that a solution like this can definitely change things, right? So I looked at this all flash array, and I saw what they were doing with the resiliency of the actual platform. And the fact that they're 1U, so I can have an entire cluster that's only 3U, right? Very small, very lightweight, and extremely capable of being able to ingest all of this data because of its high performance. And then being able to encrypt it and compress it and and dedupe it too. So that we're kind of utilizing that. And then, well, what do we do for connectivity? And we're looking at the gateway, the edge gateway, because it does have LTE. It doesn't necessarily, we may run into places where there is cell phone connectivity, right? But we want to be able to provide wireless. We want to be able to use things like LoRaWAN and Zigbee, to be able to create these mesh networks where they don't ever exist, right? And then, have battery backup. Utilize things from APC they make this really, lightweight. If you've ever dealt with, uninterruptible power supplies and you've had to move them around in the past, they were all lead acid battery. Well, now they're all lithium ion. So when you're looking at the weight of some of these power supplies and the capability of being able to generate power, they're phenomenal. So, put one of those in there, right? And then a sensor platform utilizing Intel. And I've been working with Intel for years. I was one of their original customers on their very first RealSense depth camera. But now they've got a ton of other cameras. They got this LiDAR camera, the 515. It's the size of a hockey puck, right? I mean, it's extremely inexpensive. Then you've got a tracking camera that you can utilize software to no matter where you're moving, that it keeps track of where that object is. You put that on a gimbaled platform, right? And then you take a look at their depth camera. Their depth camera now can model and do three-dimensional depth modeling up to 20 meters. And you pair that into Intel's, open source, OpenVINO, machine learning vision kit. Then we're going to be able to say, don't jump in the water, or there's a dog over there, or there's a snake over there, or there's a threat over there, right? Look at white water, see if water's moving, right? We can see without, with all of these different sensors and record it and go through that, entire process. So through that system, design, we're going to put all this stuff together. We're going to mount it in that flying platform, right? And we're going to put it into this. This is the new Hoverwing. This is the new one that we're going to be putting together, right? Still removable wings. The top is removable. We've shielded the lift fan so that, objects can't, easily get into it. Still have all the same operating characteristics. And it's a good looking vehicle too. The rigid wing that we actually created, we worked in unison with the United States Air Force Academy. Dr. Tom McLaughlin helped develop a wind tunnel model to get us a really good wing shape. So that's like the new vehicle that we're going to be looking at building. So that's all well and good, but I mean, what exactly are we going to do? Yeah, we'll put the equipment in there. We'll have this really great looking vehicle. But as I mentioned before, this is a technology demonstration platform for our customers, right? And for our vendors. This is where I take my perspective and we turn it into actionable data. This is how we show our customers how to do this, right? Not just art of the possible, not just, oh yeah, you could do that. We could put something like that together. This is how you're going to be able to do it. Best practices, blueprints, solution sets to be able to do that. And then if you take that, in my previous presentation, I had a question like, well, what other use cases can you do other than just disaster response? Well, you can apply this towards cargo transport, range operations, surveillance, autonomous vehicle testing. We have built autonomous vehicles on these platforms for the US military, right? Maritime security, threat response deterrence, personnel transport, it seats 6 people, as well as ambulance services that are not necessarily disaster related. If you look at the type of neck and back injuries that happen with people on wave runners, and ambulances can't get out to those people, especially if it's swift water, right? So we want to be able to take all of that, create all of the solution set, and turn it into a technology demonstrator, right? But what about part 2? You mentioned, if you saw the link, this is all about part 1. That's exactly what this is, the Multipart Series, right? So part 1 was, I'm telling you all about this. Here's why we're going to do this. Here's the impact that we're going to be able to provide. Well, now part 2 is we're going to build it out. And we're going to chronicle the progress, good or bad, right? If there's something that we learn along the way, or we got to add a new, vendor or bring additional things in based upon stuff that we've discovered, then we're going to do that. And then we want you to see it in person. All right. We want to be able to show you that this is the art of the how. This is how you're going to be able to provide things like that, right? Take you for a ride. It's not just going to be the vehicle and the operator in this big platform. This is a small subset of what's going to be inside there. And then we can start collecting data and analyze it. And then we want to present that data, which will help us open up new opportunities to make that impact, right? I do not want personally to jump in to chest high water in any town that has been flooded again. I want to stay on top of it. And if I do get in the water, I want to know that that water is safe and the people that are with me, that their lives are safe, right? And right now, across the globe, that doesn't exist. It truly doesn't. So that's part 2. And then later, right? What do we do with all of this? I'm talking about actionable data, right? Well, there's, this pandemic and post-pandemic, the surge of data that is being performed. What happens if we get a natural disaster during this pandemic, right? How do we integrate with other agencies during all of this? Do we implement blockchain to create these secure supply chains for equipment as we start to roll this out? There's a couple of other acronyms called Beacon and Oasis. That may be another, description for the future, right? But these are things that Sterling is looking at it in terms of new technological platforms. And then I mentioned quantum computing, and this is not like some buzzword that you always see in the press. I'm an actual certified quantum programmer. I've worked with D-Wave systems for about going on 4 years now. And I work on all the other different types of quantum platforms. So now imagine being able to take this data, put it into a system that's 150 million times faster than any piece of silicon, and do something with it that enables you to save lives. And then, take the Internet of Things, take those sensors, do something with all of our vendor platforms, right? And then develop artificial intelligence from client to cloud using, TensorFlow or Watson or Soul Machines that will, enable you to do some digital human and AI. So I hope that you kind of understand where I'm headed towards this, where Sterling is headed towards this, why we believe that this is so important, and how much we're willing to be able to help you solve your problems. And with that, I thank you for your time. I know your time is valuable. Thank you for signing up for this, and I'm open to questions.
Chris, thank you so much. We will give it a minute or two to see if any questions come in. I will say on behalf of Dell, we're very excited that you've chosen some of our products for this project and mission. And we really appreciate your partnership. Let's see, doesn't look like any questions yet. So if nobody else has anything, thanks again, Chris. This was really insightful, really great presentation, great mission, and we're really happy to be a partner with Sterling. For those of you on the phone, please do not hesitate. Please reach out to any one of your contacts from Dell and or Sterling, whether it be about the Hoverwing or any of your technology needs or questions. Please take a look at Chris's email on the screen and to either reach out, thank him, ask questions, anything at all. With that, I will go ahead and close this. Doesn't look like any questions have popped up. So thanks again, everyone, for your time today. We really appreciate it, and take care.